Okay, so what we're going to do in this video is take a look at a network analyzer. Right now I'm taking a look at the screen of the network analyzer, and I'll zoom out a little bit. We can see that the network analyzer has, again, soft buttons to the right of the screen. If I pan over here, what I see is the output of the transmitter section of the network analyzer, and here's the input connection to the receiver. So what a network analyzer is basically is a transmitter-receiver combination where I sweep across a frequency range which I can select with the front panel buttons, and my receiver sweeps across that same frequency range, and then I display what I see on the screen over here to the left. Now, right now, I don't have anything connected to the receiver, but what I'm going to do is take and connect the transmission line, and what you'll see is that on the screen there's a flat line up the very top of the screen. I might be able to zoom in on it a little bit, and it turns out that that's what we'd expect. The transmission line would let everything go from the transmitter to the receiver. I'm going to take and change the frequency here. The start frequency, I'm going to start at 0 megahertz, and the stop frequency, I'm going to go to 1.3 gigahertz. And you see that actually now the transmission line has some loss. If I go all the way up to the 1,300 megahertz, there's a little bit of loss in that transmission line. So that's a kind of interesting thing that we all know that transmission line acts like low-pass filter, so there we can see that result. Now what I'm going to do is disconnect this, and I'm going to take instead put in the path to the receiver a Mini Circuits Lab low-pass, it's a band-pass filter, not a low-pass, but band-pass filter. And I attach it to the input of the network analyzer as so, and then I'll connect the transmission line to the network analyzer. When we scan back over to the signal response, and I pan out a little bit, we see this nice band-pass filter response. I'll take and hit the marker button here, and the marker allows me to take and go up and see that, about 154 megahertz is where the band-pass filter starts, and it tails off just at about close to 200 megahertz. So from about 150 to 200 megahertz, the band-pass filter lets signals through. This is probably made by Mini Circuits Lab for some type of cable TV application. Nevertheless, the network analyzer allows us to see the response quite easily. If I go and do hit the average button here, and I wasn't able to show you this before with the spectrum analyzer. With the average button, you notice that over the course of time, noise on average is equal to 0. And it turns out that you see how, as I leave the averaging on here, the noise has diminished, and I get a better display. I'm going to go back over to change the frequency. I'll turn averaging off. I'll change the frequency. Now let's take a closer look. Certainly from about 0.3 megahertz to 1,300 megahertz, the band-pass filter is down in the lower frequency range. So what I could do with frequency is I could take and start the frequency at, say, let's say 100 megahertz, and stop the frequency at, say, 300 megahertz. And now I see the response of that band-pass filter a little bit more accurately. I could take and use my marker to take and see exactly what's going on in the pass band and up above the pass band, and maybe see what the center frequency is. So it turns out that I have these capabilities with this network analyzer. Of course, you can tell how old it is, but if I pan over here to the side, notice that what it has for an output or to save the records are an old floppy drive. So that tells you a little bit about the age of this guy. So let's take this guy off, this filter off, and see if we have any other little toys we can put here. Now, it turns out that there's end connectors. So what happens is usually these network analyzers come with special cables, and you need a bunch of different adapters usually to take and deal with them. So I've got a N to SMA connector here, and again, this is a special cable from Mini Circuits Lab. The reason why we use special cables is that turns out we want repeatability. That is, we're trying to characterize some device under test, and we want to be able to get the same results every time we take and look at that characteristic. So here I've now got this special cable here connected, and I'm going to use an adapter over here. That's an N to SMA adapter, and I have a couple Mini Circuits Labs filters here, so I'll take and screw this guy on. I won't take a look and see which one it is. We'll find out as we go along here. And then what I'll do is I'll take and bring this guy over here and hopefully connect him like so. And you'll notice that we see some type of different display. You got to be very careful not to cross thread these guys. So I may have to get up when I do this, just to make sure I don't cross thread anything. There we go, finally. So now, if I take a look back at my display, I kind of see a straight line, but again, we're only going up to about 300 megahertz. So let's take and do the frequencies again. We'll start at 0 megahertz, which is actually 3/10 megahertz, and we'll stop at 1.3 gigahertz again. And what we see is this display, which appears to be some type of filter, usually a low-pass filter. And if I take my, my marker, and I take and change its frequency, I get up here and discover, let's do auto scale first. And here we are at about 850, oh goodness, just change it. I always do that. It turns out that, again, the last control that you used, that's now the variable control. So I have to hit marker. And if I hit marker, then I see that I'm at about 847 megahertz, about 850 megahertz. So I know from past experience, this happens to be the Mini Circuits Lab. It's a low-pass filter that has a cutoff at 850 megahertz. And again, this is on my Bodie plot, basically, using this network analyzer. I've got one more filter I'll toss on here, so I'll get up and do that again. It's not easy to use these adapters. SMA is a little bit problematic. They will do a little bit easier that time. And now we see that something's happened. The display is way over on the left-hand side now, and what's happened is I have a, let's see if I can bring my marker over. I zip over here, it's 300, 200, I get to about 100 megahertz, goes up, aha! At about 46.753 megahertz rather, the response to this thing starts to fall off. So what this is, a low-pass filter. I change my frequencies again, do my start at 0 like I did before, do my stop at about 100 megahertz. And what we see here, I hit marker again so I don't goof up again. Now we see that we have about 50 megahertz. This thing starts to fall off and it drops down pretty fast. And this is a 50 megahertz low-pass filter from Mini Circuits Lab. So again, another Bodie plot basically of what the device under test is, this little blue filter here. And it turns out that the network analyzer, again, can give you good characterization of components. That one shows the transmission. If I hit measure here, I was looking at transmission, I could see reflection. And notice that at low frequencies, I'm very down in the dB value now, minus 30 dB roughly, minus 25, minus 20, stuff like that, where there's hardly anything reflected. Everything goes through, but then it turns out when I go above that frequency, above the 50 megahertz, that everything gets reflected. So it turns out that what happens is that the low-pass filter is not allowing frequencies above 50 megahertz to make it through. So again, I have this measurement capability, transmission or reflection. And I can probably do both at the same time, but it's been a while since I set this up, so I won't bother to try to figure out how to do that right now. Okay, that's about it for this network analyzer.